Hello everyone, my name is Shreya. Welcome to my channel, and today I will be talking about convergence. First, we will go over some visual examples, and then I will introduce you to the formal definition of convergence. The sequence that you see right here is a monotone decreasing sequence. That means that after every successive step, the values in my sequence get smaller and smaller. Now, let me show you the specific epsilon neighborhoods. What I mean by that is I have some bound above L and some bound below L. Let this length be called epsilon. So this is L plus epsilon right here, and this is L minus epsilon. Now I can define some value n. So let's draw a line right here, and let this be n right here. Now notice that for all n greater than or equal to n, the values in my sequence an fall within this tube that I have just defined. Also note that we are not concerned with the values that come before n. They could either fall within the sequence or they could fall outside of it. We are only looking at the values that come after n. Now, let's look at an example with a much smaller epsilon neighborhood. So this is what I have right here. This right here, let's call that L plus epsilon 1, and let's call this L minus epsilon 1. Now I can define a different value n. So let's draw a line right here, and let's call it n1. Now I want you guys to notice something. I have my two different values for n, and because my epsilon value got significantly smaller here, my n1 is also a bit larger than my n. So I had to kind of shift forward to ensure that every single element in the sequence after n still falls within this tube. So in a more formal sense, we can write for all n greater than or equal to n1, my elements in the sequence an fall within this neighborhood. Now let's see what happens when we pick a significantly large epsilon neighborhood. So let me come down here. This right here is my epsilon neighborhood. So I've got L plus, let's say, epsilon 2, and I've got L minus epsilon 2. Now let me define another value for n. I can say, let's do this right here. We'll call this n2. Same thing that we've been doing for all n greater than or equal to n2. The elements in my sequence will fall within this neighborhood. So before, when we decreased the size of our epsilon neighborhood, my n had to move forward. But now notice, because we have increased the size of our epsilon neighborhood, my n2 is allowed to be much smaller. So when we look at the region in which my sequences will fall in, we get something like this. This is our shaded region in which the elements of my sequence A sub n will fall into. One thing I want you guys to take note of is not all converging sequences are monotone decreasing. Some of them can be monotone increasing, and some of them even oscillate between larger and smaller values. In fact, that's one of the more common converging sequences that you may see when you take a real analysis course. So now let's move on to the formal definition of a converging sequence. So the formal definition of a converging sequence of convergence is for all epsilon greater than. So the formal definition of convergence is for all epsilon greater than 0, there exists some natural number n such that for all n greater than or equal to n, my a sub n minus L and the absolute value of that will be less than epsilon. So basically, if I simplify this inequality, we'll get something like this. We'll get a sub n minus L, which is less than epsilon. And if I add my L to both sides now, so I'll get L minus epsilon is less than a sub n, which is less than L plus epsilon. And if you remember, this is exactly how we've been visualizing it. I define some tube around L. I have L plus epsilon and I have L minus epsilon. And every single element in my sequence, a sub n, after my value n, falls within that neighborhood. So this is the formal definition of convergence, and this is how you can visualize it. Please like, share, and subscribe if you enjoyed watching this video. In the next video, we will be talking about some applications of this definition. We will look at some examples of convergent sequences. We will also look at divergent sequences and how they contradict the definition of convergence. Thank you.